Hello and welcome to Chapter 2, Section 4. So we talked about all kinds of equations, single step and multi-step. This time we're going to work on solving equations with a variable on each side of our equation. So before we did multi-step, now we're going to take it to the next notch and solve problems where the number we're looking for, our variable, that letter, is not just on one side, but it's on both sides of our equation. So we're going to have to combine some like terms, group some things together. So with a few steps, we can get there. So we'll see the word identity thrown around, and that just means when something is equal to itself. So we'll see that in an example as well. So here's our first one. We see our variable in this case is the letter C. Notice it's on the left and the right side of our equation. So in order to solve this thing, we need to get all the C's together. We need to get them all on one side of the equation. The way we do that is by combining like terms. We have to move them either to the left or to the right. So either way we can do it. So the first step is to have your original equation. Now from here you can either move the numbers that you have here, or you can move your variable, so whichever one you want to move first. So say we take our C's and we're going to move them all to the left side of the equation. We do that by subtracting 7C from both sides. That will cancel out the C's on the right, and on the left side we'll have negative 2C left. So after subtracting 7C from both sides, now we have negative 2C on the left. The point of doing that is that we now have all of our C's grouped together on one side of the equation. Now we can get to solving for what this value is. So since we have that, now we need to deal with this constant over here. And the way we're going to do that is by subtracting it away. So we want to get C by itself eventually. So let's get rid of this 8 through subtraction. These will cancel out. On the right, we'll just get a number. That is negative 10. Now we have something we can really work with. Negative 2 times some number will give us a negative 10. What is this some number? What does it have to be? And if you're thinking about it, you know we can divide both sides by negative 2 to find that solution. And C has to be a positive 5. C has to be 5 here. 10 over 2 is 5. Negative over negative becomes a positive. You could check your answer by substituting 5 back into the original equation. So if you came up here and said 8 plus 25, that would be 33. Does that equal 7 times 5 is 35. Minus 2 is also 33. So if you plugged it back in, it would in fact work. So for 1A, our solution, C equals 5. We moved our variable and we got there. 1B, we want to solve this whole thing here. We see our variable this time is the letter F, and it's on both sides of our equation. So let's move our F's to the left side. We want to get them all together. So the way I can do that is subtracting 3 F's from both sides. Take away 3F from both sides. So 9F minus 3F, what's that going to give me? 9 minus 3 is going to be 6F. 6F minus 6. And on the right side, 3F minus 3F cancels out, so that goes away. We're left with just 7. So 6F minus 6 equals 7. Now we're back at what we were at earlier in this chapter, solving multi-step equations. So we can add 6 to both sides. If I add a 6 on the left, I have to also do it on the right. On the left, this will cancel out. We'll be left with just 6F on the left. On the right, we'll get 7 plus 6 is 13. And the last step is to divide away the 6 so we can get F alone. So this will cancel out. We'll be left with just F. and f equals 13 over 6, which you can rewrite as 2n 1/6. So the solution for 1b is letter choice C. Just a few steps, we move our variable to one side, and then we're back to solving simple multi-step equations like we've already practiced. So 1b should be letter choice C. So 2a, we see here we have the variable q. It's on both sides of our equation. So we're going to have to simplify, use our distributive property, move some things around, and solve for that variable. So the first thing we have to do is make sure we have our original equation. Once we have that, we now need to distribute everything that's there. So I know 1/3 of 18 is 6. 1/3 of 12 is 4. Here 6 times 2 is 12q. And 6 times 7 is 42. So we distribute all of those things. Now we're at a position where we can really start to do some damage and solve for this variable. So we have q on the left, q on the right. We need to pick which way we want to go. So if you prefer to have your variable on the left side, you can just keep doing that. So we'll get rid of the q's on the right side by subtracting away 12q from both sides. So these q's here will cancel out, and we'll be left with q only in the left side. So on the left, we'll get 6 minus 8q, because 4 minus 12 is a negative 8. On the right, our q's canceled out. We're left with just a negative 42. Now we're back at what we were working on yesterday. So 6 minus 8q equals negative 42. We can subtract 6 from both sides to get rid of that constant. So our 6's cancel out on this left side here. On the right, we get negative 48. And now in one final step, negative 8 times what number will give me a negative 48? If you can't tell, you can divide both sides by a negative 8. And q would equal a positive 6. Has to be a positive 6. If you wanted to double check that, of course, you could also go back and plug in a negative 6 into this whole equation here and check to see that it is a true statement. And I can tell you that it is. So q is 6. So here's one more example we can work through. We need to first distribute our number here to every term. So 6 times 3r and 6 times 4. We'll do the same thing here, and we'll get some values. And then we can work on moving our r's together. So 6 times 3, I know is 18r. And 6 times 4 is negative 24. That will equal 3/8 of 46. So 3 times 46. Six times 3 is 18. And 3 times 4 is 12. So 138. 138 over 8 plus 8. What is 3/8 times 8 is just 3. So now we can simplify this whole thing. Oh, don't forget our r's right here. So let's work on this fraction here. So does 8 go into 138 evenly? 46 times 3 is 138, that's true. 8 times 10 is 80. And 138, take away 80, is 58. Okay, so it looks like this is going to be a fraction here. So we'd have to move all our r's to the left side. This looks like it should be 138 divided by 8 would be 10 would give us 80. And then we have to get to 58. I know 8 times 7 is 56. So this is a little bit more than 17. So if we estimate and just call this 17r, where is that going to get us? So we take away 17r from both sides, we would get r on the left. If we add 24 to both sides, we would get 27 on the right. So we know it should be close to 27. Now remember we said it was a fraction. So looking at these answer choices, we should get letter choice B. And it looks like our answer here is actually 36. So this fraction here is estimated at, and we'd have to put that in the calculator to be exact. We can go back and double check though and make sure that this 36 works, and it will for this problem. So as long as you know how to distribute and you can make sure that these values are accurate, you'll be okay when you're doing this problem. So this one is 36 for our variable r. Again, just make sure you can distribute and move those things around and you'll be okay. Okay, so we can find special solutions when we're given a complicated expression. So the first thing we need for 3a is to write our original equation. Next, if we distribute, we'll get this whole term here. 8 times 5 is 40, 8 times 2 is 16, 10 times 32 is 320, and 10 times 4 is 40. We can subtract 40c from both sides. That'll get our variable will actually eliminate. And we talked about these before. So when your variable is eliminated from both sides of your equation, this is going to be a special case. If the statement is true, you have all real numbers. If the statement is a lie, there's no solution. So since our variable disappears here, we're left with just numbers. These two are not equal. This is a lie. This is a false statement. Since it's a false statement, our answer is no solution. So this one is no solution. We have those steps there, and we understand that since our variable was eliminated, this cannot be a true statement. It's no solution. So 3b, we want to solve this whole thing here. We have t on the left and t on the right, so we can fix that with distributing and simplifying. So first we have our original equation. The next thing we'll do is multiply everything out. So we'll distribute our 4 on the left, as we see here. We'll distribute our 1/5, as we see here. Now we need to move everything around, but notice what we have here. We have the exact same thing on the left and the right. Okay, if you wanted to take it a step further, you could eliminate your variable by subtracting 4t from both sides if you wanted to. So if you did 4t subtraction on both sides, this will go away, this will go away, and you'd have 80 equals 80. And now since the variable's gone, my question to you is this a true statement? It absolutely is. So since this is a true statement, your answer should be all real numbers. So any value of t will work for this equation. But you can just write all real numbers for 3b. And we've worked on these special cases before. So 3c, we need to solve for our variable a. Given what's here, we can see what's what if we quickly distribute. So 2 times 4 I know is 8a. 8 times 2 is 16. 8a over 3 times 3, well, the 3's would cancel out there. So I'd get just 8a. Minus, and 3 times 10 is a negative 30. So 8a plus 16 equals 8a minus 30. If I subtract 8a from both sides, these will cancel each other out. So we'd be left with 16 equals negative 30. So now our variable's gone. We have numbers on both sides. It's either going to be all real numbers or no solution. This is a lie. This is not true. Since this is a lie, we know our answer is no solution. There's no number that would work for this one. So 3C, we should have D, no solution. 3D. Quickly here, we need to also make sure we distribute again. So 1/7 of 21 is 3C. 1/7 of 56 is 8. 3 times C is 3C. 3 times 8/3 is just 8. So we have 3C minus 8 equals 3C minus 8. Hey, these are the same on both sides. Right away, boom, done. All real numbers. Any number will work for this because we have the same thing on both sides of the equation. So the answer should be C. It's true for any value of C. That's our answer for 3D. There we have it. So these are just an overview of steps for solving equations. We always know we need to distribute first, simplify anything we can. We use those properties we talked about, adding and subtracting. And then the last thing you do is multiply or divide. So a quick standardized test example. We can find the value of h for these figures that have the same area. So we know that our area is base times height divided by 2 for a triangle. So they say the areas are equal. In other words, the area of this triangle and the area of this triangle have to be the same. So what's the area of this triangle in algebra? Well, it's 1/2 base times height. The base is 6. The height is just h. So 1/2 of 6h. Half of 6h is just 3h. So 3h must be equal to whatever we get over here. 1/2 of the base is 10. If we cut it in half, that's 5. So we get 5 times h minus 2. 5 times h minus 2. So if this is true, we can distribute this 5. So on the right, we should get 5h minus 10, and that equals 3h. Now we need to move the h's to the same side. So if we subtract 3 from both sides, I'm going to move this over here. On the right, we would get 2h minus 10. On the left, now we have 0, since we subtracted that 3h away. If we add 10 to both sides, 10 equals 2h. And if we divide away the 2, 10 over 2 is 5. That is equal to our height. So if we did all those steps correctly, we substituted, we know the answers that wouldn't work. And if we plugged in a 5, we would get a true statement. So the answer for this standardized test example should be D. H has 5. So D is the true answer for this one. This is 4A. One last problem, we can see the same thing here with the area of these figures. They say the areas are the same, so which one of these would work? Well, if I just plug and chug, I can check and see what's true. So if x is 1, the area of this rectangle would be 6. So for A, we'd have 6 for the rectangle. Here we'd have 1 plus 4 is 5. 5 times half of the base would be 5 times 2, which is 10. 6 does not equal 10, so A is wrong. If we did 2, 6 times 2 would be 12 for this one. So 12 for the rectangle. Does that equal what we get here? So again, half of 4 will be 2. And here we plug in a 2. 2 plus 4 is 6. And 6 times half of our base, so 6 times 2 is 12. Is that true? Well, yes, it is. So right there, we know B has to be our true answer there. And there we have it. So if you're feeling okay, you understood all those, you'll be all right as we progress forward and start our practice. That is it for this section.